Thank you very much. Thanks, Olivia. Okay, let me set up here. So hopefully not too many sore heads in the house this morning. Who was out partying? Liars, like 2 people. Thanks for coming in bright and early to see me kick off the execution stage here at UXDX in Dublin. My name's Nick Crabtree. I'm going to be talking about migrating systems to the cloud and zero downtime releases. And when I say that, I think we all know that I mean monolithic legacy systems, which is a problem that we're all going to face at some point or another. So let's just talk about terminology briefly. A legacy code base is essentially one to which you are no longer willingly and actively adding features. It's likely to use older frameworks, code styles, architectural patterns, hosting technologies, and it is therefore, by definition, the ugly stepsister of the shiny new code base. Because of that, people are unlikely to want to work on it, and that's going to cause problems with motivation. Over time, that's likely to cause problems with attrition, and then you can't hire good people to come and work on it, and so on and so forth. So a monolithic code base is almost certainly a legacy code base. The reverse is not true. A legacy code base doesn't have to be a monolithic code base. But a monolithic code base is probably legacy simply because we now know that there are better ways of doing it. We may have known then as well, but we don't talk about that. It has to be built and deployed in its entirety. It's probably composed of tightly coupled interdependent components, which are probably communicating in process. You might find that your presentation and your logic are all mixed up, so you can't make a change to them independently and deploy them that way. When you do deploy, it almost certainly is going to involve a complex, sequential series of time-consuming or manual steps, and that often means that deploying it means downtime. So what are our options in this case? Well, we could leave it. I think we all know that this is deferring the problem. The cost of maintenance is going to continue to rise, and not just in time and effort, not just in motivation and attrition, but you'll find that with older technologies, there is a rapidly diminishing pool of resource because people no longer have the skills or the desire to work with those technologies. So at some point, you're going to have to do something with it. Option 2, you could bin it and build a shiny new utopia of new frameworks, new technologies. You can, go wild with all this great stuff that you've only read about. This is the stuff that developers' dreams are made of, but probably not commercial success. You can't just just throw away the old system, do nothing for a while, whilst you go and play with the new tech. It seems very unlikely, although it would be nice, right? So that brings us to the third one, which is fix it. And I think when we say fix it, what we really mean is we're going to keep the old system rolling whilst we change the wheels, probably also the engine, the chassis, respray it, and we're not allowed to pull into motorway services unless we absolutely have to. So how do we go about fixing the big ball of mud? Essentially, we need to break it up into smaller balls of mud. We need to scoop out the insides of those balls of mud, and then we need to clean up the mess. You could also look at this very much like the plot of the film Invasion of the Body Snatchers, where they send down small spores that then grow into exact duplicates of the things that are already there, and then they dispose of the waste afterwards. This occurred to me that this film is like when it was 1950-something, was definitely defining patterns for modern software architecture. Watch it again, you'll see what I mean. So before we go into how we break it up, let's talk about some fundamental guiding principles. We need to understand what we're doing. We need to understand the impact of change. And therefore, we don't make a change to anything that is not under test. Why? Because we just don't know if we've broken something until it's too late. It might seem like a good idea. It might seem that we're using the right tools for the job and we've done everything properly, but in actual fact, when it's too late, the whole thing comes off the rails. Right? So breaking stuff means downtime, and again, that's not something that we want. Tests ideally assert the behavior of the system when compared to the requirements of the system. That's not always the case with a legacy system. You may have so few tests that you've no idea what the system really is supposed to do. You may have so many tests that you've absolutely no idea what the system is supposed to do. So what we can do in this case is use something like characterization tests, where we retrospectively write tests, automated tests, that say this is how the system currently behaves. And that gives us a baseline to say, when we change something, we know we haven't broken it. The current behavior of the system might not be the desired state, but that must be our minimum kind of baseline of what we're going to go with the new system. We can't break stuff, make it worse. Ideally, we'd have a properly shaped test pyramid, and not some kind of abstract cubist nightmare, but it has to be balanced with the benefits when you think about the effort it takes to build a proper test pyramid for a legacy system that ultimately you're moving away from. So if you understand the behavior of the system right now, you probably have enough to move forward. Constrain your scope. This is really important. When you're moving especially from a monolithic system to a shiny new system, then you can imagine that business and tech alike are likely to see this as an opportunity to shoehorn in everything on their Christmas list from this year, last year, maybe the year before. They've all been waiting. We've been waiting for this moment. But it's pretty much a direct path to failure. We need to constrain both our new features and our emergent design. We need to make some big decisions up front about how we're going to go about it, what we're going to do, and we need to stick to them. We need to make some big decisions about our big box architecture up front, and we need to stick to them. We need to lay out an appropriate but limited set of technologies and build the new system on them. And then we need to give the teams the autonomy to go and make something they're super proud of, but within those constraints. After that, you can start talking about continuously improving, adapting. You can change those small balls of mud into completely different languages, frameworks, whatever you want. They don't have to be in any way related, but during the carving up of the system, it's really important to keep that scope as tight as you possibly can. Automate your pipeline. This man in this film embodies the automated pipeline in all its glory. This is Groundhog Day. This man wakes up every day, and it's the same day. But it's not exactly the same day. Every day, he makes a minor incremental improvement to the way the day goes. And over time, the day becomes absolutely slick from start to finish, right? He knows where stuff's coming from. He doesn't even have to think about it. He just sails through the day. And ultimately, that's what we want when we build an automated pipeline. We want it to just happen. We want it to be slick. We want to commit some code. We want it to go through to production. Maybe we don't. Maybe we want it to go through to a state where it's ready for production. But ultimately, we don't want to have to do that stuff. We want it to be as polished as it possibly can be. So automated tests are where we want to be. If you saw Scott talk yesterday about the benefits of manual test and the human element, that is absolutely a good way to get going, right? When we work in an agile fashion, we try to avoid doing big stuff up front. And the same is true for an automated pipeline and a set of automated tests. If we can get going, and we can do so with manual test, then we absolutely should, and we should build that pipeline as we go. If we can use exploratory tests to determine the behavior of the current system, then we should absolutely do that. Get going quickly, release in small increments, classic kind of agile XP type stuff. Automated build gives us that repeatability and consistency. Every time we build, it builds on my box, cannot be a thing, should not be a thing in this day and age, but I think we all know that it is. Automated deployment, that opens up our ability to run automated functional tests. So at that point, we can automate our tests of the behavior of the system. If we've written those characterization tests, that's a perfect time to do it. So we know that we haven't broken anything compared with the old system. Automated provisioning. Automated provisioning opens up our ability to spin up and also to spin down environments in a known state every time. So you have no configuration drift, no patch drift. You don't have someone going onto the box and tweaking something about, now it works, brilliant. When you move to another environment, it doesn't, because no one remembers what changed. So automated provisioning, especially if you're able to do this in a cloud provider, also gives you the benefit of cost savings. So you spin down those environments at night, you spin down those environments at the weekend, and the amount of money you save in doing that in a large environment is surprising, motivating, let's call it. And all of this is ultimately what we all call our CI/CD pipeline. It's really important to get this stuff in up front, at least plan to do it, plan to increment over it, such that your feedback cycles are kind of shorter and shorter as you go. You want to relentlessly shorten your feedback cycles such that you can get change into production through test as quickly as possible. Collaborate. This is super important. Collaboration is your key to success in any big kind of replatforming or migration exercise. If you're breaking down that big ball of mud into smaller balls of mud, and those teams are going to start to have autonomy, you need to be able to talk to each other. You need to be able to exchange ideas. It's like that if you're having meetings, you're probably not collaborating well. There's a difference between, it's like the difference between me cooking dinner, realizing to my horror that we have no lemon-soaked paper napkins in the house. So I just get on the phone, I go, can you pick up some lemon-soaked paper napkins on your way home? Done. Brilliant. Versus me, setting up a meeting to talk about the stocking and ordering times of lemon-soaked paper napkins, which means that I'm still not going to have one by the time I need it. It's not collaboration. If you're setting up meetings, it's probably too late. Go and talk to people. People like to be talked to. If someone comes and asks you a question, it's a sense of achievement to be able to help someone and answer that question, share your knowledge. It should be that way. So let's talk a little bit about how we might break it up. So bounded context, something that was introduced to us in domain-driven design. A bounded context represents a purpose within your domain. Back in the day, we all thought it was a great idea to have a universal, unified, global data catalog or global data model that modeled our entire business. But anyone who worked with one of those, I'm sure many of you have, will realize that it was a nightmare to set up. It was a nightmare to maintain, and it was a nightmare to implement. So the idea of bounded context was that you can have the same thing in multiple smaller contexts within your business. And although it meant the same thing, it didn't have to be implemented in the same way. So you would therefore provide some mapping between the two, and each bounded context was master of its own destiny while still working as a cohesive whole. We use well-defined interfaces to make sure that other people know that when we talk about a person, it's the same kind of person that they're talking about, and how we can map between the two, that kind of thing. When we separate those models into our bounded context, it also then facilitates the separation of the classes, the components, and so on that implement them. And that means that we then have control over the code in our bounded context to do with as we please. So let's have a quick look at a bounded context. We might have, for example, at a large online fashion retailer, a product, a customer, a payment. This is essentially a checkout process. You put a product in your bag as a customer, and you pay for it. Cool. We also have visual merchandising, so the people who make our products look nice on the site, they put them in the right place, just as when you walk into a shop, the thing that you want is right at the back, so that you have to walk past every other item to go and get it, so that you might buy more stuff. For them, a product is slightly different. They don't necessarily care directly about the stock of that product or the price of that product. That might influence the visual merchandising, don't get me wrong, but they're not going to use those precise values at the product level as you would in the checkout. Identity, our ability for a customer to log on to our website, to identify themselves, cares about the customer, but cares nothing about payments or the product or anything else. Product, customer, and payment is also the bounded context of refunds, for example. Different things, completely different actors, completely different ends of the business, working in reverse, but different bounded contexts. So once we start to draw these lines around the bounded context, it allows us to start to break up our big ball of mud into logical parts. We can then go from there to the more kind of physical parts. For example, a microservices architecture. Doesn't have to be a microservices architecture. It could be any architecture. But ideally what we want is to be able to contain, to encapsulate parts of our business. And that includes the way that we present it, expose it to external consumers. That might be a web front end, or it might be another API, or it might be directly to the customer. We want to be able to encapsulate the logic, the models, the data storage, the logging, monitoring, security, and we want to be able to release that stuff at will, independently of all the other small balls of mud, which hopefully by this time are no longer balls of mud, but shiny, beautiful balls of shiny. So we can take these small components, and they all work together beautifully. If anyone remembers Terrahawks, if you don't, I'm sorry for you. So let's talk about some patterns that we might use to break down our monolith. So Strangler pattern, based on the Strangler fig, a plant which essentially grows from the top of a tree down into the ground, roots itself in, and then over time gradually kills the tree that's hosting it and takes over. Nasty, but essentially the Strangler pattern approach is to add new stuff in the new way. And then the old way, the old part of the application essentially just dies off. And over time, your new application parts become the application whole, and the old one dies off. It's fairly high level, but it's probably easier than trying to rewrite in situ the older parts of the application. So you might want to have an anti-corruption layer. So an anti-corruption layer is just a bunch of stuff that stops your old, nasty monolith from contaminating or corrupting your new stuff. Your new stuff will likely use a set of interfaces defined between tech and business to do what you need to do. They're probably lightweight. They're probably arranged in such a way that you can do lightweight messaging, event sourcing, whatever it might be. Your old system is probably going to return you some gargantuan XML document that you then have to filter and parse and everything else. Chances are you're still going to need that in this interim stage. So what you do is you put in a layer of components that take on board that translation, that mapping, whatever it might be. So your new system essentially has no idea what the old system looks like, which is a good thing. So there are a few patterns that we can use within our anti-corruption layer. One is the adapter pattern. So the adapter pattern essentially provides a new interface over an old interface. Quite simply, you can take one of your old classes in your old system, you have an adapter. The new system can use that class as if it were a new class. So the adapter basically just says, yep, yeah, I'm one of these shiny new ones, and then goes off and does all the nasty mapping and whatever else it does at the back end. There's also the facade. The facade pattern is essentially presenting a subset of a larger interface. That might help you to start breaking down, especially if you're moving into something like a CQRS architecture. You want to break up your commands and your queries. You may use a facade to essentially pretend to be a command or a query, even though in the interim, they're using the same monolith behind that. There's also a translator, essentially an adapter, but for messaging. So it will do some mapping. It will take in a message and say, yep, I understand that. That's the nice new one, and then map it to the old one and pass it on. And then once we have scooped out the insides of our little balls of mud, it all looks the same. We've taken the big ball of mud. We still have lots of small balls of mud. Our system is doing the same thing. It's performing in the same way that it was before, in terms of behavior. Hopefully, not in terms of actual non-functional requirements. Hopefully, it's faster. It's more easily monitorable, but it looks the same to external consumers. So at that point, we want to clear up the mess. We want to hose down our small balls of mud to reveal the new balls of shiny underneath. And so we want to decommission the strangled components, for example. If we've moved over to new components, the old components may still be there. We don't want them. We don't want them taking up money. We don't want them taking up support costs and time and so on and so forth. So cleaning them up is really important, and you need to be aggressive about that. With an old system, a system that maybe nobody fully understands, you will have those moments where you say, ooh, maybe I'll just leave it because someone else might be using it. That's not the way forward. You need to do this stuff. You need planning. You need courage. And you need to do this stuff aggressively. So pare down your system. Once you've moved over some functionality, take out the old stuff. you would want to collapse your anti-corruption layer. If you've got an adapter that's pretending to be the old interface, hopefully by this point, you no longer need it. The old system is gone. So you take out those adapters, those interstitial kind of components, simplify your architecture, simplify your routing. You may have been using some kind of blue-green deployment. We'll talk about that in a sec. Simplify your routing, your network layers, your calls, all that kind of stuff. And then you should, hopefully, be in a position where you can deploy at will. You can get features in front of your customers much, much faster, much more rapidly. And the really important thing is that you are confident, because of your automated pipeline, because of the smaller scope of your change, that when it goes into production, it's going to work. So whilst we do all of this stuff, and then beyond, there are some methods we can use to ensure that we have as little downtime as possible, ideally 0 downtime. Immutable infrastructure, we talked about, you provision. When you deploy, you provision. And that means that there's no configuration drift, there's no patch drift, blah, 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 blah. Telemetry. You need to know what your system is doing at all times. Logging, monitoring, alerting, anomaly detection. If your system goes wrong, if something happens, someone says to you, what's wrong with it? You need to have an answer. You need to have an answer, because if you don't, it's just sitting there in production and it's not working. Security. Don't underestimate security. If you were to put a new virtual machine on a public-facing IP, in 90 minutes, the thing would be broken. It would be attacked. It would be starting to explore other virtual machines on your network. It would start to be finding vulnerabilities. It's a serious problem, especially when you're working at scale, especially when you're a big name, even if you're not. Even if it's your personal virtual machine you've put up there in your personal developer subscription, there are vulnerabilities and there are attackers who are constantly scanning this stuff. So security, if you've got a security breach, it's not only your downtime that's a problem, it's your reputation as well. Blue-green deployments. So blue-green deployments is essentially taking 2 sets of architecture, deploying your new stuff to one, and then gradually feeding traffic over to it. And you can do this using, in Microsoft Azure, you've got Traffic Manager that allows you to use a weighted round robin, or you can direct traffic specifically to different endpoints. You can do various things in Akamai, for example. When you're happy that it's working, you start to feed more traffic over, and then the environment that you've left behind is then essentially your staging kit, and so you keep swapping. Canary deployment's a similar thing, but instead of separate architecture, it's a subset of your architecture. So you might deploy to 1 or 2 servers, or you might deploy a few services, and again, you use some kind of weighted DNS, round robin, whatever it might be, to start feeding traffic over. It allows you to see the things scale up, so you're not only testing that the code that you've written works and that the infrastructure works, but also that it can scale properly. And if it's not working, you simply just switch off that traffic and go back. And then feature toggles, obviously. At the code level, you can say, if you pass in this value, then you'll get this feature, or you won't. Or you can use API versioning, resource versioning, all of these kind of things to limit the access to your new stuff until you're happy that it works. And you can roll out that full release to all of your customers. Thank you very much.
Thank you, Nick. Thank you very much. That was really interesting.